Okay, gentlemen. 7.2 is over arithmetic sequences and partial sums. Let's define those to start with. So the definition of an arithmetic sequence. A sequence is arithmetic when the differences between consecutive terms are the same. So essentially what this means is that we are adding a constant to get to the next consecutive term. We call that constant that we're adding the common difference. And that is because if we subtract any two consecutive terms, like if we do a2 minus a1, or a3 minus a2, or a4 minus a3, it will give us that common difference that we add to get to the next term. Let me give you a few examples of arithmetic sequences. So we're looking at the sequence defined as 4n plus 3. So a1 would be 4 times 1 plus 3, which is 7. A2 would be 4 times 2 plus 3, so 8 plus 3 is 11. A3 would be 4 times 3 plus 3, so 12 plus 3, which is 15. Notice what our common difference is here, right? If I do 11 minus 7, I get 4. If I do 15 minus 11, I get 4. So this is an arithmetic sequence with common difference 4. All right, let's try another one. In this case, an is 7 minus 5n. So a1 is 7 minus 5 times 1, which would just be 2. a2, 7 minus 5 times 2, which is negative 3. 7 minus 10 is negative 3. A3, 7 minus 5 times 3, so 7 minus 15 is negative 8. Notice in this case, if I subtract negative 3 minus 2, I get negative 5. Negative 8 minus negative 3, I get negative 5. So this is a situation where the number we're adding, the common difference, is negative. Okay. And our last one here, we got the sequence defined as the nth term is n plus 1/4 times n plus 3. So a1 is 1/4 times 4, or just 1. a2 is 1/4 times 2 plus 3, so 1/4 times 5 is 5/4. A3 is 1/4 times 3 plus 3, or 6/4, which can also reduce to 3/2. All right, so if we subtract these, 5/4 minus 1 is a fourth. 6/4 minus 5/4, or 3/2 minus 5/4 is also a fourth. So here our common difference is just a fraction, which is 1/4. So these are 3 examples of arithmetic sequences. Just to give you some contrast here, if I look at the sequence 1, 4, 9, 16, whose nth term is n squared, this would not be arithmetic, because if we try and look at the differences between the terms, right? 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7. So we don't have a constant common difference, so this would not be considered an arithmetic sequence. Okay, so let's take a look at the pattern in our arithmetic sequence. So the first term is just whatever our first term is. To get the second term, if you know the common difference, you take your first term and you add that common difference. Really, we're adding 1 times that common difference, right? To get the next term after that, we would start at the first term and we would add 2 common differences, right? Because adding the first one gets me the second term, and then adding another gets me to the third term. To get the fourth term, we would take the first term and add 3 common differences. And to get the fifth term, we would take the first term and add 4 common differences. So what we want to use is this pattern to go ahead and develop a formula to find the nth term of any arithmetic series? Well, note that whatever term we're looking for, like in this case, we were looking for the fifth term, we added one less than that number of common differences to our first term. So we're always starting with our first term, A1, and we're adding one less than whatever our index is times the common difference. So we're just going to call that n minus 1 times the common difference. And now we have a formula to find any term we want in any arithmetic sequence, right? So it's just find the nth term. It's your first term plus n minus 1 times the common difference. So just take a minute to make a note of that. That's a formula we're going to be using quite a bit. All right, let's see it in work. So I'm trying to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Whoops, so I'm just going to start with my general formula for the nth term. And we're going to make a note that they told us the common difference, d, is 3, and the first term, a1, is 2. So we're going to take that information and plug it into our formula. N equals 2 plus n minus 1 times 3. And then we'll just simplify this as much as we can. So I'm going to distribute the 3. We're going to get an is 2 plus 3n minus 3. And then we combine the 2 and the negative 3. We get an equals 3n minus 1. There we go. Now we have a formula to find the nth term of the sequence described in this example. All right, let's try a different example. So I have that the fourth term of an arithmetic sequence is 20. I'm going to write that out. So A4, I know, is 20. And the 13th term is 65, so A13 is 65. And I want to write the first 11 terms of the sequence. The first thing I want to figure out is what the common difference is. And the easiest way to do this is think about how many terms it takes to get from the fourth term to the 13th term. Well, 13 minus 4 is 9. So it takes me 9 terms to get from the fourth to the 13th term. So because this is arithmetic, I can think of that as if I take 20 and I add 9 common differences, so 9 times whatever my common difference is, that should get me to 65, right? Now I just have a basic algebra 1 equation that I'm just going to solve for my common difference d here. So subtract 20, 9d is 45, divide by 9, d is 5. So now I've figured out the common difference that I'm adding is 5. So I want to write the first 11 terms. Okay, so I know the fourth term is 20, and I'm just going to keep adding 5 to get to my next term. So 20, 25 is my fifth term, 26 is my sixth term, 27th is my seventh term. Nope. Sorry, I'm supposed to be adding 5, got carried away there. 25 is my fifth term, 30 is my sixth, 35 is my seventh, 40 is my eighth, 45 is my ninth, 50 is my 10th, and 55 is my 11th. And then to go in the opposite direction, I'll just subtract. So this is my fourth, so my third would be 15, second is 10, first is 5, and there we go. Now we've found the first 11 terms of the arithmetic sequence. Okay, another example. Find the 9th term of the arithmetic sequence whose first 2 terms are 2 and 9. All right, so I know A1 is 2. I know A2 is 9. I know this is arithmetic. So my common difference can be found just by subtracting any two consecutive terms. So I'll just do a2 minus a1, which gives me 7. And then I can just apply this to my nth term formula, which is my first term plus n minus 1 times my common difference. So in our case, an would be 2 plus n minus 1 times 7. And we'll go ahead and distribute the 7. We can just make a simple formula here. So 2 plus 7n minus 7. And I get an is 7n minus 5. All right. And then to answer the question, we want the ninth term. So I'll go up here and just say a9 and just follow my formula. That's 7 times 9 minus 5. 63 minus 5, which is 58. So the value of my ninth term is 58. Okay. So to find the sum of a finite arithmetic sequence, sometimes we call this partial sum. So the sum of the first n terms can be found using this formula. And that's just the number of terms divided by 2 times the quantity, your first term plus your last term. Okay? So just label these for us. Remember, n is the number of terms. A1 is your first term. An is your last term. All right, let's do a couple examples of finding these sums. So I want the 150th partial sum of this arithmetic sequence. 5, 16, 27, 38, 49. Okay, so a couple things I need. Remember, I'm going to be looking for the 150th partial sum. So that's going to be 150 divided by 2 times my first term plus my last term is A150. The first thing I need to do is figure out those first and last terms. Well, I can see that A1 is 5 here, but A150 I don't see right away, and I don't want to just keep adding whatever my common difference is. In this case, it's what's 16 minus 5, it's 11, right? My common difference is 11. I don't want to keep adding 11 150 times to figure it out. So we're going to default to using our nth term formula, right? So a sub n is your first term, which in this case is 5, plus n minus 1 times your common difference, which is 11. All right, so if I want A150, all I have to do is 5 plus 150 minus 1 times 11. That's 5 plus 149 times 11. And if we pop that in a calculator, it comes out to 1,644. There we go. My 150th term is 1,644. And now I can use my partial sum formula. Sum of the first 150 terms would be 150 over 2 times 5 plus 1644. That goes in a calculator, and we end up with 123,675. All right. Just so that we have the practice, let's do another one that's similar. In this case, I want to find the 16th partial sum. So my 16th partial sum is going to be 16 divided by 2 times my first term, I can clearly see here is 100, plus my last term, which is going to be the 16th term. And I don't know that yet. So again, if we're going to find our nth term, it's going to be our first term plus n minus 1 times our common difference, which in this case, notice that our terms are decreasing by 5, so our common difference is negative, so times negative 5. All right, so A16 is going to be 100 plus 16 minus 1 times negative 5, which, again, we'll go ahead and just pop that into a calculator, and we end up with 25. My 16th term is 25. Now the sum of the first 16 terms is 16 over 2 times 100 plus 25. 16 over 2 is 8 times 125, which is 1,000. All right, and that's it for arithmetic sequences. Please get started on the group work and then the delta math.